In this video, we'll talk about naming with transition metals. I'll be honest with you, this is probably what students find most frustrating about the naming topic. So please make sure you're paying very close attention when you're learning this. It is very important. Transition metals are the elements in the middle of the periodic table. So we're talking about these here for purposes of our class, okay? We're not really going to deal with these here, and there's some over here, but we're going to deal with this here. What makes transition metals more difficult for naming is that transition metals can bond with a shell that's not their outermost shell. They can bond with other shells. So they can form, the bottom line is, they can form more than one ion. They are metals, so they're still cations. But because they can form more than one ion, they're going to form more than one compound with the same nonmetal. So for example, iron can form Fe2 plus and Fe3 plus, and every element is kind of different what it can and cannot form. When iron combines with oxygen, it can form FeO, which you can probably tell is the reduced or simplified form of Fe2 plus and oxygen. Right, because that would be and then it would be simplified to FeO, and then Fe2O3. And you can see these two are very different here. The Fe2O3 is this bright red color, and that is what we would normally think of as rust. You'll often hear rust referred to as iron oxide, but that's not totally correct, because iron oxide could be this black powder over here, and that's not what you would normally think of. So we need to know how to tell the difference between these two versions of iron oxide. So what we do is we use Roman numerals to show the charge on the metal. Now, we don't have to worry about the nonmetal, because nonmetals cannot form more than one charge. Oxygen can form a 2 minus charge, that's it. So we don't have to worry about that. What we need to do is tell what version of iron are we working with here. So we know that this version of iron was the 2 plus, this version of iron was the 3 plus. For the 2 plus version, we would write iron 2 oxide. So this charge on iron becomes a Roman numeral. So that one would be FeO once you simplified it. For the 3 plus version, we would write iron 3 oxide. So this 3 charge on iron goes right there. So I think it makes name to formula easier, but formula to name harder. So let's quickly go through name to formula and then work on formula to name. Name to formula is easier because you only have to look up your non-metal on the periodic table. The charge of your metal is right here. So copper gets a 2 plus charge. Chloride is chlorine, so you can look that up on the periodic table and see that it gets a 1 minus charge. You then crisscross them and you get CuCl2. Here you have cobalt with a 3 plus charge. Sulfide is sulfur. You look that up on the periodic table and it gets a 2 minus charge. So you have CO2S 3. So very similar to what we did with just simple ionic compounds, except now you don't even have to look up the metal. Go ahead and try these, and then come back for the answers. Manganese is Mn. This Roman numeral is a 6. Phosphide is 3 minus. When we crisscross that, we get Mn3P6. Do not forget that you can simplify ionic compounds. These are still ionic compounds. So don't forget that you can simplify this into MnP2. So this should be your final answer. And then here we have titanium, 3 plus. Fluoride is 1 minus. So you get titanium, TiF3. Okay, ionic compounds, formula to name. You do the same thing, you write the first element, which is the metal, you write the second element with IDE, but now you need to figure out the Roman numeral. Very often it's just the subscript on the nonmetal, right, because of the crisscross. But remember we have that silly simplifying thing, so we need to check. So to check, I do something I call the reverse crisscross. In order to check the Roman numeral, you do the reverse crisscross and check the charge on the nonmetal or the anion. Because the nonmetals can only have one charge, so you have to make sure it has the right charge. Let me show you what I mean. Here we have chromium, bromide, and then I'm going to reverse crisscross. When I say reverse crisscross, I just mean subscripts become charges. Because usually when we're crisscrossing, our charges become subscripts, right? So now I'm going to make the subscripts charges. So I'm going to rewrite my elements and move the subscripts to the charge position. And you can put the plus and minus if you want. The first one always gets the plus, the second one always gets the minus. But honestly, you don't have to. It's not really going to matter. Here is the important part of the reverse crisscross. You now need to make sure that your anion or your nonmetal has the correct charge. So here we have bromine with a 1 minus charge. If you look up bromine on your periodic table, you need to see what charge bromine has. Bromine has a 1 minus charge. Great. We have to do nothing. Our anion checks out. So all we have to do is take the charge on the metal and make it the Roman numeral. Don't forget that it's always the charge on the metal because you're checking the anion, but then you have to use the charge on the metal to make the Roman numeral. So sometimes people get thrown off by that because it's just so much work. But just take your time, make sure, especially when you're first learning, take your time and make sure you're doing it correctly. So here we have copper sulfide. We do our reverse crisscross. We have ones for both subscripts. So we get 1 for both charges. We then need to check our nonmetal. So we look up sulfur on our periodic table, and we see what charge does sulfur get on the periodic table. Sulfur is right here. So look, it gets a 2- charge. But in our problem, it has a 1- charge. So that tells us that our formula had been simplified. Okay, so we need to get it back to what it was before we simplified it. Okay, so that means it's kind of like this iron 2 oxide. Okay, we need to have the charge on the original ion. So we need to unsimplify this almost. So let's talk about what we do. We have to multiply to get sulfur to be the correct charge. So right now it's 1- and it needs to be 2-. So we're going to multiply by 2. You cannot just multiply sulfur though, they are stuck together. So if you multiply sulfur, you also have to multiply copper, which makes sense because if we simplified a formula, we simplified both subscripts, right? So then we get Cu 2 plus S 2-. That checks out. So now the copper charge can be put into our Roman numeral. Okay, go ahead and try these two, please. So here we have titanium fluoride. When we reverse crisscross, we get 4+ for titanium, 1- for fluorine. If we look up fluorine on the periodic table, it is 1-. So this 4 becomes our Roman numeral charge on titanium. Then we have nickel oxide. When we reverse crisscross, we get Ni2O1. When we look up oxygen on the periodic table, the charge should be 2-. Here it's 1-, so this must be a simplified formula. So we'll multiply by 2 to get oxygen to be its rightful charge. That gives us Ni4O2-. Now oxygen is correct. So this one is also 4. And that's it for naming transition metals. We will do a lot of practice on this to make sure that you know when to use a Roman numeral and how to get it. 2 mistakes people make: they don't check the anion to make sure it wasn't simplified. And also, now that I teach you about Roman numerals, I start seeing them everywhere. So now all of a sudden, sodium has a Roman numeral, calcium has a Roman numeral. It's only transition metals, so please keep that in mind.